Welcome to my class. Introduction. Class Standard 9. Subject Mathematics. Chapter name Lines, Angles and Triangles. Chapter 6, Lecture 1. Today's lesson to explain lines, angles and triangles. Concepts of space, plane, line and point. This class fully repetition from class 6 to class 8 because in this class you had already learned about this. Today I will again repeat this class. Okay, and exercise 6.1 and 6.2, these two exercise will read properly because that are important for MCQ and creative A number question. Especially for MCQ, these two chapters are very important. Okay, so everybody will read properly. Okay, now follow. Space, the space around us is limitless. It is occupied by different solids, small and large. By solids, we mean the grains of sand, pen, pencil, paper, book, chair, table, etc. Okay, the concept of geometry springs from the study of space occupied by solids and the shape, size, location and properties of the space. A solid occupies space which is split in three directions. That's mean that are dimension. This is spread in three directions denotes the three dimensions. That's mean direction. This is a dimension. That's mean length, breadth and height. As for example, like as brick or book. Okay, those have length, breadth and height. Clear? A sphere also has three dimensions. Okay, although the dimensions are not distinctly visible, it can be divided distinctly into length, breadth and height. Okay, follow the figure. The boundary of a solid denotes a surface. The boundary of a solid denotes a surface. Follow the figure here, like as brick. Here this is a surface, this is another surface, this is another surface and this is another surface. That's mean this side and also this is a surface total. That is, every solid is bounded by one or more surfaces. For example, the 6 faces of a box represent 6 surfaces. The upper face of a sphere is also a surface. Upper face of a sphere is also surface. But the surfaces of a box and a sphere are different. The first one is plane, while the second is one curved. Clear? Two-dimensional surface. Two-dimensional surface mean a surface whose have only length and breadth. Okay, the each surface of a rectangular solid. This is a two-dimensional. Is here 6 surfaces. Each of them are two-dimensional. Clear? That's mean it has only length and breadth, but no thickness. You have to remember. Okay. When two surfaces intersect, a line is formed. Clear? That's mean when two two surfaces intersect, a line is formed. For example, two faces of a box meet at one side in a line. This line is a straight line. Again, if a lemon is cut by a knife, a curved line is formed on the plane of intersection of curved surface of the lemon. Line. A line is one-dimensional. It has only length and no breadth or thickness. If the width of a face of the box is gradually receded to zero, we are left with only line of the boundary. In this way, we can get the idea of line from the idea of surface. That's mean from idea of surface, we can say or we can write which one is a line. Okay, and we know more definition of line. Line means whose initial and ending point are absent. Next I will explain. The intersection of two lines produce a point. That's mean when two planes intersect each other, then a line produce, and when two lines intersect each other, then a point is produced. Okay, that is the place of intersection of two lines is denoted by a point. If the two edges of a box meet at a point has no length, breadth and thickness. If the length of a line is gradually reduced to zero, here will be also reduced, not receded. Okay, that will be reduced to zero. At last it ends in a point. The other point is considered an entity of zero dimension. That's means zero is a zero dimensional. You have to remember, because that type of question are important for MCQ. Okay, depend on line, surface, plane and space, we can write the Euclid's axioms and postulates that are important for MCQ. Also postulates for plane geometry. Okay, just you will read properly and you will get the idea. Okay, line, ray, line segment. Follow a figure here. A, C, B. Here are AC, this is a line segment. CB, this is also line segment. That's mean part of line. And line, here AB is a line because it has no initial and ending point. But CA or CB, CA initial point C, ending point A is limitless. Here B is limitless, that is B is moving, A also moving. Okay, so CA is a ray, also CB is a ray. That's mean when initial point present but ending point absent, that is a ray. And when both initial and ending point are absent, this is a line. Okay, and both initial and ending point present, this is the line segment. You have to remember. Okay, angle. When two lines meet at a point, then produce angle. When two lines meet at a point, then produce angle. Here POQ is an angle. Straight angle. The angle made by two opposite rays at their common endpoint is a straight angle. Common midpoint here is A. Okay, In the adjacent figure, a ray AC is drawn. AC is drawn from the endpoint of A of the ray AB. Thus, rays AB and AC have formed an angle BAC at their common point A. Therefore, angle BAC is a straight angle. Okay. The measurement of a straight angle is two right angles or 180 degree. That's mean if a angle 180 degree or two right angles, that is a straight angle. Adjacent angle. If two angles in a plane have the same vertex mean here A, and same or common side, okay, and the angles lie on opposite side of the common side, that's mean this angle and this angle are opposite of common side AC, okay, and common vertex, that is A. Each of the two angles is said to be an adjacent angle of the other. That's mean CAD is adjacent angle of BAC and BAC is adjacent angle of DAC. That's mean common vertex present, common line present. Clear? And then produce two angle or opposite angle, each of them are adjacent to each other. Right angle. If two adjacent angle are equal, that's mean DAC and BAC are equal, then it is called right angle. When two adjacent angle are equal. If two adjacent angle are on the same line and equal, that's mean one condition will be are on same straight line and equal to each other. That's mean two adjacent angle are equal when these two angle produce on same straight line. Same straight line, that is a condition. Then the angle is called right angle. Okay. Acute angle and obtuse angle. Acute angle means measurement of angle less than 90 degree and obtuse measurement of angle greater than 90 degree, that is obtuse angle. Here AOC is a obtuse angle, acute angle, or BOC, this is acute angle, but AOD, this is a obtuse angle because this is greater than right angle. Right angle means AOB, this is a right angle. So AOC is a less than right angle, so this is acute, and AOD greater than right angle because from here to here that is a right angle, as AOD from here to this point, so AOD is a obtuse angle. Reflex angle greater than angle greater than 180 degree but less than 360 degree, that's mean greater than two right angles but less than four right angles, then it is called reflex angle. Complementary angle. If sum of two angles is equal to 90 degree, okay, the two angles are called complementary angles. Here AOB is a 90 degree angle, sum of BOC plus AOC, this is equal to 90 degree. So BOC and AOC are complementary angles. Supplementary angle, sum of two angles, this is equal to 180 degree, as AOB is a 180 degree angle and sum of AOC and COB is equal to 180 degree. Therefore AOC and COB are supplementary to each other. Vertical angle. Two angles are said to be opposite angles if the side of one are the opposite rays of the other. Are the opposite rays of the other. That's mean OA and OB are mutually opposite rays. Also OD and OC are mutually opposite rays. Clear? Therefore, the angle BOD and EOC are a pair of opposite angles. Similarly, BOC and DOA or AOD are another pair of opposite angles. Therefore, two intersecting lines produce two pairs of opposite angles. That's mean vertical opposite angle of angle AOD and BOC are equal. Also AOC and BOD are also equal. Theorem 1. The sum of the two adjacent angles whose a ray makes with a straight line on its meeting point is equal to two right angles. Again follow the sum of two adjacent angles which a ray makes with a straight line on its meeting point is equal to two right angles. That's mean angle AOD plus angle DOB. This is equal to two right angles. Now follow the proof. Let OC meets, that's mean OC ray meets the straight line AB at O. As a result, two adjacent angles AOC and COB are formed or produced. Draw a perpendicular DO on AB. Okay. Sum of the adjacent two angles, that's mean angle AOC plus angle COB. But angle AOC, this is equal to AOD plus DOC, and this angle same, that means COB. Now follow AOD plus DOC plus COB. That's mean this two, this equal to, we can write DOB. That's mean DOB. Now this, as AB is a line, so this angle, that's mean angle AOB. This is the two right angles on 180 degree. So sum of two angles, that's mean AOD and DOB equal to two right angles. Clear? Theorem 2. When two straight lines intersect, the vertically opposite angles are equal. I had already explained about this. Here two lines, that's mean AB and CD, be two straight lines which intersect at O. As a result, the angles AOC and angle COB and angle BOD and angle AOD are found at O. Angle AOC opposite angle DOB or BOD. Again angle COB, this is equal to opposite angle AOD. Clear? Now parallel lines. Alternate angles, corresponding angles and interior angles of the transversal or interceptor. Follow here AB and CD, two parallel lines, and EF, this is the transversal or interceptor of the parallel lines AB and CD. Then produce angle 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now follow here one number. That's mean angle 1 and angle 5. Angle 2 and angle 6. Angle 6. Then angle 3 and angle 7. Angle 4. Angle 8. 4, 8. That's mean this and this are equal and corresponding angle. Okay, this and this also equal and corresponding angle. this and this, that's 1 and 5 corresponding angle. But angle 3 and angle 6, that is a alternate angle. This angle and this angle. Angle 4 and angle 5 are alternate angle. That's mean this angle and this angle are alternate angle. Angle 4, 6 are interior angles. 4, 6 on the right side, and 3, 5 are interior angles of the left side. Okay. And this exterior, this and this are exterior, no problem. Triangle. A triangle is a figure closed by 3 line segments. The line segments are known as sides of the triangle. The point common to any pair of sides is the vertex. We know this. The sides form angles at the vertices. A triangle has 3 sides and 3 angles. Dependent side, the triangle are in 3 kinds. Also, dependent angle, the triangle are 3 types of 3 kinds. Now follow. Equilateral, when all sides are equal of a triangle. Isosceles, if 2 sides are equal of a triangle, then it is called isosceles. Scalene triangle, if all sides of a triangle are not equal, that is scalene. Acute angle triangle, if all the angles are acute angle, that means A is acute, B is acute, C is acute, then it is called acute angle triangle. Right angle triangle, if one angle is 90 degree for right angle, then it is called right angle triangle. Obtuse triangle, if one angle is obtuse angle, then it is called obtuse angle triangle. Interior and exterior angles, here this is a exterior angle. Interior, this is interior, this is interior, this is interior. But exterior angle, this is equal to sum of 2 opposite angles. Sum of 2 opposite mean as the opposite angle of, see, this is this and this. So exterior angle ACD, this is equal to sum of 2 opposite angle mean CAB plus ABC. That's mean CAB plus ABC, this is equal to angle ACD. Okay, you have to remember. So the student, chapter 6, theorem 1 up to 4, you had already proved from class 6, 7, especially 6 and 7. Okay, and make 10 MCQ on the lecture with answer. Okay, and submit the copy in the group. Date of submission 24/2021, time 11 AM. Today after this, thank you to all everyone. Okay, goodbye.